Hello, my name's Gordon McKay. I'm doing this presentation over geosynthetics right now. Sorry if the way the PowerPoint is set up is weird. It's the only way I could get my face video on here as well as a PowerPoint, but whatever. Let's go ahead and get started. So my presentation is over geosynthetics. Here is the table of contents outline. We'll just start off with the introduction, so we'll go ahead and get started. So the introduction, our geosynthetic is a material that is defined as a planar product manufactured from a polymeric material, and so it's used and integrated with rock, soil, and other stuff like that in a number of civil engineering projects. And most of the materials it's made from are polyester, polypropylene, or polyethylene. And these materials are included of geowebs, geogrids, geonets, geomeshes, geocomposites, geotextiles, and a few others. And I'll get into the definitions of those as we go on. So there's many applications like filtration. It can be used to filter water through soils to allow the soils all stay together instead of moving through the material. It can be used to drain water as well through low permeability soil. It can be used to separate different types of materials and foundations, uh, such as a fine grained soil or a coarse grained soil. Geogrids or geotextiles are often used to reinforce the load bearing capacity of a lot of soils. So, if it's laying down like a highway or something like that, it can reinforce the load bearing systems. And it's also used a lot to control erosion so that a lot of materials and soils do not get eroded or stuff like that. Many different types start off with geotextiles, or more like a fabric, almost like a composite material like that. They help reinforce, drain, and protect the qualities of soils. Usually they are woven, needlepoint, or heat bonded, made of polyester or polypropylene. A geonet is a type of material that is consisted of integrally connected sets of ribs overlaid at different angles for in-plane drainage of liquids or gases. GeoWeb consists of a lot of strips of materials laid down, crisscross pattern, and they're welded together in different layers to create more strength for roadways, pavements, or load-bearing systems. GeoGrid is a rigid type of rib of material made of polyester or polyethylene. They're usually thicker and they have a lot of open spaces. They're better at reinforcing and sometimes used in filtration or drainage. A geocomposite is kind of like a mixture of any of these types of materials to do any different types of tasks like that. They can also be used to filter, used to reinforce the strength, but it's more like a combination of a geotextile, geonet, or geogrid. All right, so now we'll get into the pros or the cons of using geosynthetics. So, to start off with the pros, there's relatively low cost. It's easy and convenient to install for most applications. It's a quick and effective protection against erosion. The designs are available for many different uses, and there's a lot of variety of designs to choose from for your different projects. And if the integrity of the material is kept together, it can be removed and reused for different projects. Now, for the cons, if the material is selected incorrectly, the design might not be suitable, and basically then you just waste all your money on one material and be costly to replace. Many of geosynthetic materials are sensitive to light degradation, so it's important to protect the material before you install it so that the integrity isn't compromised. Geosynthetic that are not degradable should be used where their visibility creates an aesthetically unpleasant environment, and if damaged, the effectiveness of the material can be drastically altered. One of the good reasons to use geosynthetics is because it is economically feasible compared to using other materials. So what that means is that you can save a lot of money in the reductions and substitutions of soil materials. So what that means is that it's basically cheaper to use a geosynthetic than to use a different type of soil or soil substitution. Um, it saves a lot of money and easy of installation. The life cycle cost savings through improved performance by increasing the longevity of the projects. So it basically it increases the lifespan, and it increases the sustainability. So it's good for the environment, and basically Now that there's been a lot more different types of developments in geosynthetics, it's become a lot more cheaper to use because a lot of different companies are making a lot of different types, so they've become cheaper. The installation, so installing geosynthetic material, it's pretty simple because most of them just come in a really big rolled up layer. So you just get one huge roll, as you can kind of see in these pictures, and then you lay it on onto your subgrade and you literally just roll it out. So it's very easy to install, and it makes a lot of ease of installation for contractors. You don't need a specialist to come install it. It's pretty simple to do in a short amount of time. Maintenance and inspection. This is an important part because if it's not inspected or maintained properly, the entire project might not be kept together as it should be. So routine inspections are required to carry out by the National Pollutant Discharge Elimination System, basically to protect the environment. And once it's installed, these routine inspections and maintenance are still required for most geosynthetic processes. If repair is necessary, sometimes the entire geosynthetic material has to be unearthed. Sometimes you can't just replace it, and where the section is damaged, you have to take out the entire thing, which that could be really expensive. Safety. So most of the safety that comes along with this is basically safety in keeping the integrity of the material together. It's not that dangerous to install a geosynthetic itself because it's just a large roll of material. However, it can be dangerous sometimes. So when installing and applying geosynthetics, contractors must take their time and be very attentive while rolling out and applying the materials to make sure everything gets put in properly, doesn't cause problems further down the way. And then environmental safety is a big deal because if the geosynthetic material has not been approved or selected properly and you put any type of chemical in the environment where you're not supposed to, that can be very expensive or even illegal. And the future of geosynthetics. So today, geosynthetics are mostly used in the strengthening of soil and soil layers under roads and pavements. However, advances in technology are making geosynthetics available to be placed inside concrete and even asphalt to make those stronger as well, which is a big, a big step forward from just increasing the strength of soils. And the growing market of geosynthetic is growing every day, and it's estimated to reach $22 billion by 2027. So it's really an expanding market, and the geosynthetic segment of the market is the largest growing. The amount of geotextile expected to be manufactured and sold is estimated to be 6.6 billion square meters by 2027 as well. So it's it's booming as a way of soil advancements. And so basically, just as an overview, in general, geosynthetics are synthetic materials made from polymers like polyethylene, polyester, and polypropylene that become available in a fabric-like material, and they're installed in soil under pavement and to reduce erosion, strengthen load-bearing capacities, and improve damage in many heavy civil applications. And like we talked about, they come in geotextiles, geonets, geowebs, geogrids, and geocomposites. They're highly cost-effective due to their ease of installation, increase in manufacturing methods, and a decrease in time of construction. And the use of geosynthetics are growing and expected to be even more widely used year by year. And the market is expected to grow as materials become available and easier to acquire. So here's a test of your knowledge. I don't exactly know how it's going to work since we're not live in class for you to answer these, but basically, if you can answer any one of these three questions, seems like you got a pretty good grasp of the presentation. So if you can give at least three types of geosynthetic, or three reasons why they're used, or if you can give any reason why they are more economically feasible now than they were in the past, or if you can do all three, great, good for you. But yeah, then that brings me to my references. So basically, that is the end of this presentation. Thank you guys for listening and watching. I hope you enjoyed it. But yeah, y'all stay safe, wash your hands, stuff like that. Y'all have a great rest of your day. Take care.